Here we're asked about what is the best prediction for height based on shoe print length. And what we're asked to do this for is for the 19 males in the data set. The original data set contains females. Fortunately, it's already sorted for us. So what we're going to need to do first is get rid of all the data on females. So now it's going to be the same process. There's two things that we would use to make the prediction. We would use the mean to predict height unless we can establish a relationship between height and shoe print length. To do that, we're going to take a look at the scatter plot. We're going to take a look to see if the correlation is greater than or equal to the critical value. And then the last thing we need in order to use the regression equation to make a prediction, if we have those first two things, is that our given x value of 31.3 is an interpolation. So what I'm going to do is just to kind of go a little bit out of order, but to get it out of the way, I'm going to get the mean height right off the bat. So once I'm done with that screen, I can get rid of it. That's 182.62. Why am I going out 2 decimal places? Because my original data goes out 1 decimal place and our general rule of rounding is 1 beyond that. Now, analysis, correlation, and regression. So we're going to use shoe print length to predict height. At least we're going to investigate that. So evaluate, scatter plot. And here we do see a positive relationship. We do have a trending upward as we move to the right. So it's linear, it's positive, but given all the spread of the points, that appears weak to us, or at least it does to me. But because we said linear, that's enough for us to move on to correlation. Is there a significant correlation? That's going to be a yes, and our explanation, our one and only explanation, is because the R value, the correlation coefficient of 0.594, was indeed greater than the critical value, which was 0.456. So even though it looked like a weaker relationship, we do have a significant linear correlation. We can move forward. Now our regression equation, that's going to be y hat is equal to 93.5 plus 2.85x. So we have our correlation is significant. We have our regression equation. We have our mean height. And the shoe print length of 31.3, that's about right there. It is an interpolation, so we're fine to go ahead and use the regression equation. So at this point, we're going to have a little bit of arithmetic to do as we go ahead and take our regression equation here and replace the x with 31.3, and from this point forward it's a bit of arithmetic. So I went ahead and did the arithmetic that we had to do. I also fixed my typo of the decimal place. It's 2.85 is our slope. So our predicted value of height for a male with a shoe print length of 31.3 centimeters is 183. Now, how much faith can we have in that prediction when we have a weaker correlation? Probably not that much, and we see this in the scatter plot. There's a lot of variation in the heights. So, we have our predicted value, but again, these y-hats, these predicted values, they represent our prediction of the mean for everybody that has that shoe print length. So if we had us collected a bunch of people whose shoe print lengths were 31.3, and we took the mean of their heights, we're predicting that mean would be 183 centimeters.